Momentum and Rotation Review 7. Determine the velocity of the center of mass of the two-object system shown. Whenever we find the center of mass of something, here we're going to find velocity. We talked in a previous video that what you do is you take the reciprocal of the total mass, 1 over the total mass, and then you multiply by each mass times the quantity that we're after, which is the velocity of its center of mass, and you do that for every object that you have. So let's see if we can do that. The total mass is going to be 6m. So 1 over 6m. And then we need to take this first mass, which is 4m, multiplied by its velocity, which is 6v. And I put a plus there because I'm noticing in this picture that the two masses are going in different directions. And so I have to choose a direction arbitrarily to be positive, and then the other one will be negative. So I've just naturally chosen to the right to be positive. 4m times positive 6v plus 2m times negative 3v. See, that velocity is in the opposite direction. I'm seeing the m's cancel here. And what does this give us? I'm seeing 24v here, minus 6, so that's 18, divided by 6 gives us 3v. And because it's positive, it's that way. Part 2 here. Suppose the collision is perfectly inelastic, so these two collide and stick. Show that the system's velocity of the center of mass is unaffected by the collision. Momentum will be conserved. The initial momentum is going to be plus 2m times that velocity. That's the initial momentum. At the end, these two are stuck together. So their mass is 6m. And what's v final? What does this come out to be? 24 mv minus 6 divided by 6. Look at that. V final is 3v. Now, here's the deal. This positive 3v up here is the velocity of the center of mass of this system before those two things have collided. You will note that none of the mass is actually moving at 3v, but collectively, if you take all of this mass together with their velocities, the center of mass of this two-mass system is moving at that rate. So this 3v that I'm pointing at, you might think of it as an imaginary point that is just moving along to the right at 3v, even though these two masses are not in line with that imaginary point. However, if these two masses collide, that imaginary point then lines right up with this 6m mass, and it all proceeds together. So the velocity of the center of mass of a system is unaffected if those two things collide. The two objects there do exert forces. Why does the velocity of the center of mass not change? Those forces are internal to that two-object system. If we consider the system to be one of the objects or the other, then the force is an external force. But that's not what we have here. We considered this two-mass system to be the system. And so when they collide, the force that they exert on each other is internal to the system and therefore doesn't change the velocity of the center of mass.